Hi, my name's Curtis Whitson, and we're going to have a basic video about the pipette elements, the fundamental elements that are used in building a pipette project. There are only 4 of those elements, and we'll start with the first one, which is called a resource. Before we get started, the first thing you always want to do when you start a new pipette project is to save that project, give it a name. In this case, we'll call it the elements basic video. And what we can then do is to look on the directory here where we have 2 files. We're going to bring in a input file to a reservoir simulator. The reservoir simulator is the sensor compositional reservoir simulator. This is a resource element, and the file name, when you drag and drop a file into the pipette canvas, will take by default the name of the file. We can change that name easily by doing the rename. We'll call it sensor input file, and put this in parentheses just to remind us the file name. And at this point, we have the resource on the canvas, and one of the things we can do with that is look at the file. By default, we can open that in the editor using F4 or like this, and we see the typical reservoir simulation file. This is the SB3 problem, compositional 2-well injector producer model. Now, what are we going to do with this file? We're going to use it as input to a reservoir simulator, an application, this case called sensor. So we'll drag down what we call a process. This is the second element in pipette, and we'll rename this process using the F2 key, sensor. And right now it's just a graphical element. It doesn't know what to do. So we'll double click on the element, and the simplest, most basic way to tell the process what to do is simply write the command line execution for the program, and in this case it's sensor. And this is the free version that you can get from Coates Engineering website. The input file name, sp3 syn.dat, and the output file name, sp3 syn. We'll give it this name. And that's the command line to execute the program. Now, the third element we'll introduce is the connector, which connects processes with resources. In this case, it's an upstream or input resource. And at this point, we've got the resource, the connector, showing indication of direction, and the process itself. And we've told the process how to launch itself. So now we can run the program by using the run key, and it'll take a few seconds. This is a 7 by 7 by 4 sector model with I think 8 components. And now Sensor has created a number of files, output files. Perhaps the most important one that we want to look at is the .out file that we named. So we can use another way to bring that output file into the canvas is to right click, go into the Explorer, and look for all output files. We should find one right there. We'll drag it into the canvas, close Explorer, line it up, and this being output or downstream resource to the process, we'll just put a connector there. The output file, we can just take a look at it by double clicking on it. It should open the file. Look at the results. For example, how long it took to run, about 5 seconds. Results, recoveries, and so forth. So now I thought we would bring in another application. This would be an EOS PVT program called PhazeComp from Zik Technologies. And we have an input file for the PhazeComp for the same SP3 fluid characterization. We can bring that file in a different way. We'll define a resource here. We'll name it without having its connection to the file itself yet. This will be PhazeComp input. And to associate the file with this resource, we right-click and go in and set the resource file. We look for files with extension PHZ. There's one. Double-click on that, and now this file has been associated with that particular file. We want to introduce the process, which is the PhazeComp executable. So we'll bring that down here. Rename it to a program name. We have to tell this process what to do. To launch the program, we simply write the program name, write the input file name, which was spe3 pvt.phz, and we'll give an output file name like that. And we'll use the connector to denote this is an upstream file. And now we can launch the project again, and this time both the simulator, sensor, and PhazeComp will be run. Now the PhazeComp is much faster. It's doing just a few flash calculations. We can actually see that the two programs were launched in parallel by looking at the console bar and the timeline. And here you can see the total timeline. You can see which applications have been run, and you can see that these few fractions of a second they were run in parallel. Now we'll go fetch the output file to complete the project. We'll find again the output files. There's the PVT output file. Drag it in to the canvas, line it up. We can rename it. And connect it. And at this point we've got 4 resources, namely 4 links to files on the computer and 2 processes, 2 applications being launched. And I'm going to now show you the 4th and final primary element, and that is the composite. Now what you'll find is that in larger projects that you'll end up bringing a lot of files and a lot of applications into a common Pipet project, and it's convenient and useful to group together elements that kind of are appropriate to group together. So we use what's called the create composite command, and we'll now get a single element, rename it. This element is representing the reservoir simulation of SP3. Give it a name, and what's inside this element, this composite, is the original elements, resources, and processes. And we can navigate like this. It would be natural to create a second composite that has to do with the EOS PVT calculations. Right click, create the composite, rename it, SP3 EOS PVT calculations. And now we have a very tidy project. Now, if you go into one of the composites and you run the elements at this level and below, when you use the run key, it will run the applications at this level and deeper, but it won't rerun the PhazeComp, which is a different branch in the project. So it reran the sensor simulator again. Now, in fact, if we want to rerun the project, or if we try to run the simulator one more time at this point, what you'll see is that it goes very fast. And the reason it goes very fast because it hasn't relaunched the simulator, because it has a check when it runs the project whether this file has changed since the last time it was run. And since this file hasn't changed, it won't rerun the application. Now if we go into this file and make it the smallest of change, we just put another period here, save the file, leave, and then rerun it. Then you see it will rerun the application. Without the connectors, it would not know that these files were connected and the upstream and downstream dependence. So this is very important within Pipet, the connectors. So just to summarize, we have 4 types of primary elements in the Pipet project. We have the resource, which is a connection to a file on your computer or computer system. We have the process, which is any application that you can launch from your command line, can be launched as a process. You have the connectors, which identify direction of computational flow. And we have the composite, which is simply a collection of the primary elements, resources, and processes, and it may also include other composites itself. Thank you, and enjoy Pipet.